I'd like to play a little game, all right? I'm going to give you the name of an object, and then I want you to try very hard not to get a picture of that object in your mind. Are you ready? Good. First object, a red apple. Now, you're not getting a picture of that in your mind, are you? Good. You're doing just fine. Let's try another one. The Statue of Liberty. Now, don't think about what that looks like. You're not seeing it, are you? Good. One final object, a fire-breathing dragon.
And when he came to the place where the wild things are, they roared their terrible roars, and gnashed their terrible teeth, and rolled their terrible eyes, and showed their terrible claws.
People created monsters, and they created dragons to explain things that they had fears of, but they really couldn't describe. And that's basically what math is. When you enroll into some class of mathematics, the first thing you do is open up a textbook, and you see something in there that you totally don't understand, and something that frightens you totally because you have no comprehension how you're going to tackle that monster. But what this does is it takes the language of the mathematics and it makes it so sensorial and so visual that all of a sudden it is this language of mathematics no longer becomes a monster, but it has become our friend.
After 18 months of study, the National Commission on Excellence in Education recently confirmed what many have suspected for some time. The condition of education in the public schools across the United States has taken a rather dramatic turn for the worse. For the first time in the history of our country, the report concluded, the educational skills of one generation will not surpass, will not equal, will not even approach those of their parents. Although the Commission was painting a total educational portrait, in this age of rapidly advancing technology, the focal point, the area of gravest concern was the acute decline of competence in mathematics. There is good reason for concern. In addition to continually faltering test scores from high school seniors, colleges report a general lowering of mathematics standards and record record numbers of students avoiding the math curriculum entirely. To millions of students across the nation, math is indeed a monster, and the monster is not a friend. Why? Why this great fear? How is it that we find ourselves in a situation where the study of mathematics has become so frightening that students avoid the confrontation at any cost?
What mathematics is a matter of childish little concepts. I cannot think of a single concept in mathematics that isn't totally childish, totally comprehensible by a child.
Here at the Blake School in Plantation, Florida, the Alexander School in nearby Miami, and in scores of other schools from coast to coast, students are discovering that algebra, trigonometry, and arithmetic are nothing more than childish concepts, and in the process, they're chasing the monster away. For these students and their teachers, the tide of mediocrity in math education has turned. The program that has turned the tide is the Mortensen Math System. What is it? Why is it successful? How is it different than traditional math programs? The answers come from a discussion of two characteristics of the system: The first part concerns its basic premise, visualization.
In traditional math education, you are taught a rule of how to get the answer without any understanding at all of what it was that you were doing. Well, all factoring is taking the amount and arranging that amount together to form a rectangle so you can see what the dimensions are. So here, as you've seen if you've attended the workshops, by going over one amount and up the rest and filling in the rectangle, the corner, you've created the rectangle.
Remember now, don't visualize. I'm going to give you the name of one more object, and I want you to try very hard not to get a picture of that in your mind. That's the whole purpose of the game. Are you ready? X squared.
This is really fantastic, and I sat down, and as he went over how you do it, I wrote it all down because I went home to tell my husband. I thought it was really, really neat. I've gone through a lot of schooling, and I never had really pictured how these things work until he put it up. I knew it, I can do it fine, but to see it is really an excellent way to learn the math. You don't have to memorize. If you can see what's going on, you understand it.
I'm one of these basic parochial school kids that learned from the blackboard learning, and I don't remember algebra. I don't apply it to my life. I apply what I apply to my checkbook, adding and subtracting. That's it, and multiplication. Mathematics, everybody just kind of slid under their desk. Now, look, they're having a wonderful time. She's doing more than just learning off a blackboard. She's taking it to practicality, so Kelly's going to understand algebra. Where, to be very frank, I think when I was educated, you memorized it off a blackboard, you prayed you got through a test, and about 2 hours later, you hoped you forgot it because you didn't like it to begin with.
Understanding algebra. The idea of visualizing math is not only a breakthrough for parents who still struggle with math in their high school memories, but it is equally startling to a mathematician in this third year of engineering at Georgia Tech University.
Well, it's the ability to see now what you're doing in mathematics instead of just being told. You actually have it in concrete form.
And equally welcome to a junior in high school who believed she was incapable of doing math because she had always failed at it.
When she saw that it was simply a matter, that all that business of factoring was a matter of taking these blocks and arranging them to make a rectangle, now all of a sudden it was a game. It was a puzzle. Now it's not threatening at all, because we're not looking at the unknown monster. We're not looking at, you know, what is x squared, because we see what it is. What is x squared? It is a square.
I think we need to try that last one again. Now remember, I want you to make every effort not to get a picture of this object in your mind. Are you ready? X squared.
As students working with the material quickly grasp the concepts in algebra and trigonometry, one thing becomes painfully clear. We have crippled and continue to cripple students in the learning of mathematics. How?
By failing to teach them a way to visualize math the way that we visualize language. When someone says a red apple, it's impossible to consider that object without getting a picture of it in your mind. And yet we're asking math students to eliminate any kind of visual representation and deal with only abstract numbers and letters. In the Mortensen math system, students see what x squared plus 5x plus 6 is. It's a shape. It's a formation of rectangles. And when you see it that way, it's very easy to factor.
Pictures for them exactly what's happening. If you multiply 1/3 by 1/3, can you really picture how you get 1/9? Probably not, but they can. I mean, you memorize that's how to do it. They see that's why you do it.
It is not what one teaches, but how one demonstrates to a child that learning is important. It is not the activity per se, but the melody behind the words. This observation by Jerome Kagan of Harvard University underscores the second important feature of the Mortensen math system. It is fun. To simply replace a failing program with another which is more productive but equally stressful for students is only cutting off one of the heads of the two-headed monster. A successful math program must produce not just good results, but an interesting, enjoyable means of getting good results.
They started wanting to work on it constantly. There was nothing else they wanted to do. They would come in the morning and ask for new lessons all the time. They couldn't wait for the next book to come along. When they come home and they can impress their parents with what they're working on, and they find that their parents can't remember it, then that's even more exciting because they say, well, gee, my mom doesn't know how to do this, and I showed her how. And as they're working on it, we haven't told them everything as they work on it. You know, we just introduce it simply to them, and as they start working with it, they start discovering things on their own. And that makes it even more exciting when they say, I know how to do this, and I don't even need the materials. And they sit down and they say, oh, this is easy. And even with their math bees, they want to have, don't give me simple multiplication. I want give me an expression, I'll give you the factors.
They get 4 or 5 little tasks that they can do. And the first thing he excitedly did, he ran over to where the math course was, and he sat down, and he started working out these equations. He's only 4. Now, my high school educated employees, they can't do it. But my 4-year-old can do it. He thinks it's neat. It's fun.
What is it that makes Mortensen math fun?
A sense of accomplishment, a sense of I'm able to do this. That's one of the big things. And there's a continual progress, and it's deceptive in this way. It's deceptive because each of the workbooks carries it in such a small gradation that the kids think, well, this is too easy. But they're doing things that are marvelously difficult.
In the Mortensen system, we work with little student workbooks, which are about 20 pages in length, and they include one concept only, so that the child is repeating over and over again throughout that 20 pages the one concept. And there's tremendous motivation because as they finish this, they can actually see they're getting through. When you're working with a large textbook, you know that that's your work when you come in September, and it's going to be your work clear till the end of May or middle of June, whenever you get out. And it doesn't really have the motivation. You don't feel that you can finish. And here you feel that you can finish. In fact, if you want to, you could sit down and do that whole book in a day and move on to something else. And it's exciting to come up and say, can I have another book? And the next book that they would get would have one more isolation of difficulty, just one more concept for them to understand. And it builds upon what they have learned previously, so that they have that repetition built in over and over again.
Mortensen Math is a program that follows a step-by-step approach towards the visualization of mathematical concepts by simply building rectangles. A program which motivates students because it is constantly rewarding and enjoyable to learn. And yet, for any program to be successful, it must find a willing teacher. A teacher who is willing to consider a program which does not take a traditional approach to mathematics. Teachers willing to look the monster in the eyes.
Jerry first showed me the material, how to work with it, the algebra and the basic operations. I was very scared because I wasn't a very good math student in high school. It's a piece of cake. It's nothing to be worried or scared about. It's the easiest thing you can do.
And finally, the cost. A change of curriculum requires money. Stemming the tide of mediocrity not only means investigation and hard decision-making, it also means a commitment of dollars. And in a time when dollars in education are getting harder and harder to come by, teachers and administrators are obliged to take a long look at any program.
What we look for in education is something that's cost-effective. For years, we've been throwing away money on a number of things that didn't work. I see something that does work, if it works, it makes it cost-effective. Does that make sense to you?
The Mortensen Math program has only one goal: to prove to students that math is not a monster at all. When they discover that, they'll be on their way to accomplishing the math skills that will give them so many more options, so many more choices.
To me, it's sort of a default, you know, that they lose out on freedom of choice simply because they haven't had the background to make that choice. And this is what I think, starting children at younger and younger ages and really giving them the opportunity to internalize mathematics and science at a very young age will allow them then to say, hey, I can do anything I want to do. It's just a matter of me making up my mind what I would like to do.
You take small children, you get them involved doing the algebra, doing the trig, doing a total math program at a very early age, and there is never a monster there, because math is now their friend. It's something that's enjoyable, it's something that's fun, and it's something that is very understandable.
All right, the last one, x squared plus 5x plus 6. Do you see it? Good.